to what? Butanoic acid. But with pyridine chromochromate, this reaction is avoided. So it will only end here, butanol. It cannot convert butanol to butanoic acid. That is why we say it's a special oxidizing agent. So whenever you see pyridine chromochromate, know that it's capable of converting aldehyde, primary alcohol to aldehyde without converting that aldehyde to the corresponding carboxylic acid. Is that okay? So that is one way of preparing aldehyde keto by oxidation of what? Alcohol. Primary alcohol we give aldehyde, secondary alcohol we give ketone. And then we looked at some of the oxidizing agents where we said we have the alkaline potassium permanganate, chromic acid, and then pyridine chromochromate, chlorochromate, which we said is capable of only converting alcohol to what? Alkanal, without converting that alkanal to the corresponding acid. This reaction here does not take place. Is that okay? So you should take note. It's a potential exam question. All right. The next one is by catalytic hydrogenation of alcohol. Catalytic hydrogenation of alcohol. Now this one now more like catalytic dehydration, not hydrogenation. Dehydration of alcohol. When you dehydrate alcohol, you are removing what? Water. Are you getting it? So it's not supposed to be dehydration. Sorry, it's a mistake from my own side. It's dehydrogenation. Dehydrogenation. When you dehydrogenate something, you remove hydrogen, which is more like an oxidation reaction also. Is that okay? So aldehyde can be prepared by passing the vapor of primary alcohol over a copper catalyst at 300 degrees. Now this is the catalyst that is also used. Ketones are similarly produced from secondary alcohol. This is also a reduction, an oxidation reaction, but this one is by a catalyst. So that is why we say catalytic dehydrogenation, not using a reagent. So to 300 degree. Now this is a primary alcohol. 1 degree is called ethanol. What product do you think is going to form? From what we know, this one is going to remove hydrogen from here, remove hydrogen from here, so that at the end of the day you are going to have CH3, CH, and then O. Are you getting it? Plus what? H2. This one you are removing hydrogen, not an oxidizing agent. You know that of oxidizing agent we said is going to form water at the end of the day. But for this one, since there's no oxidizing agent, that oxygen to attach is going to form the what? The gas, hydrogen gas. So this here is ethanol. Is that okay? Now ketone also can also be formed from this mix by what? Catalytic dehydrogenation of secondary alcohol. So secondary alcohol is to ketone as primary alcohol is to aldehyde. Degree Celsius, and this will give us CH3, C double bond O, CH3 plus H2. This is called acetone or propanone. This is called 2-propanol. 2-propanol. Sorry, this is 2-propanol, not na, which is also called isopropyl alcohol. Why this is acetone, also called propanone. Alright, so those are methods of preparation of the aldehyde also and ketone from catalytic dehydrogenation. It's more like an oxidation reaction also, because when you are dehydrating, you are removing what? Oxygen. Removal of oxygen. Do you understand that concept exactly? Now next one, by addition of water to alkynes. By addition of water to alkynes. Now acetylene reacts with water in the presence of mercury sulfate and mercury sulfuric acid. I taught you this when you were in year 1, where I said it's like oxymercuration, demercuration reaction. It follows the Markovnikov rule. Now what actually happens here is very easy. You have alkyne, for instance, this is acetylene, all right, plus water. Water is H2O, which can be written this way too. According to Markovnikov rule, what you were taught that the hydrogen here we go to the carbon having the highest number of hydrogen, while the OH will go to the carbon behind the fewest number of hydrogen. However, both of them are having the same number of what? Hydrogen on both sides. So these are the oxidizing the agent that are mercuric sulfate in what? H2SO4. Now this is first going to form an intermediate, because according to what we know, when this one attack here, this one will come here, and when that occurs, it's going to form what we call an enol, or it may actually be the other way around, where this one here, because this at this position you have here, the hydrogen and hydrogen here are the same. We are going to look at another case. All right, so this OH can come here, while this hydrogen can come here. So when that occurs, this is going to form H2C. Now because you are adding 2 atoms to both sides, one of these bonds here will break. So whenever addition reaction occurs, a bond is broken. So here will be, you know why it's H2C? Because we've added another hydrogen to the one that was here before. There was one hydrogen here, so we added another one. There you have C. Recall that there was hydrogen here before, and here is OH. Now this is what we call an enol. It's an unstable intermediate. All right, it's an unstable intermediate. It's called an enol. Now this will undergo what we call keto-enol tautomerism. Now keto-enol tautomerism is an interconversion between an enol and a ketone. What will happen in this case now is more like an aldehyde. Is that okay? A keto group will be formed, while this enol, there will be an interconversion there. So what will happen is that this hydrogen here will leave here, a double bond will be formed here. Is that okay? And then it's more like this hydrogen here will come to this position here, or let me put it this way, that this hydrogen here will come here. All right, so when that hydrogen comes, the double bond will be broken, and then you are going to form something like this: hydrogen, hydrogen, hydrogen. Here will be C, here will be hydrogen. Because this hydrogen is no longer here, double bond will be formed here. So this will give us double bond oxygen, which is an aldehyde. What aldehyde is this? This is acetaldehyde. All right, this is an aldehyde, acetaldehyde. If you want to write this very well, you can say it's still something as what? CH3. Here's what? C double bond O. So we have C double bond O, and here's what? H. Is that okay? So that is one way. Now let's look at a situation, because this alkyne is symmetrical. Let's look at a situation where the alkyne is unsymmetrical. Unsymmetrical in the sense that you have the distribution of the hydrogen about the triple bond is not exactly the same, or is not equal. Now in this case, this is where the Markovnikov rule will take its full course. All right, in this reaction, that's where the Markovnikov rule will take its full course. Now what do you think will actually happen here, my dear student? What do you think? According to Markovnikov rule, whenever you have something like this, the hydrogen will go to this carbon here at this position that have the highest number of hydrogen. Now if you look at this carbon here, it's having 1 hydrogen. This carbon here is not having any hydrogen. This H3 here belongs to this carbon here. Are you getting it now? If you want to know, I will say this is carbon 1, this carbon 2, this carbon 3. Carbon 1 has 3 hydrogen, not carbon 2. Carbon 2 does not have any hydrogen. Carbon 3 has 1 hydrogen. our main concern is between carbon 2 and carbon 3. So between carbon 2 and carbon 3, which one have the highest number of hydrogen? Carbon 3 have 1. Carbon 2 has 0. So it means the hydrogen will come here. Alright? While the OH will come here. And of course, when that happens, the double bond will break. So my dear students, this is going to give us CH3. Here will be C. Here will be what? Told you that this OH will come here. Here will now be a double bond C, H, and then another hydrogen here. Now there will be keto enol tautomerism. This you see here is an enol, an unstable intermediate. Are you getting it now? It's very, very unstable, as you can see it here. Very, very unstable. All right. There will be keto enol tautomerism. Now, what do you think will happen in the keto enol tautomerism? This hydrogen that is here will come to this position, and if that hydrogen comes here, a double bond will be formed here, and then this double bond will break, so that at the end of the day, this is now what we are going to have. Keto enol tautomerism. You see, it's an interconversion in the sense that this enol can change to ketone, and this one can also change to what? An enol. So here will be CH3. Here will be C double bond O. Right? This double bond will now break. So you have another. I told you that this hydrogen will come here. How many hydrogens are you having here? 1, 2. Plus this one, making it how many? 3. So you have CH3. This is acetone. So this is another method of preparing aldehydes and ketone. Now the next method we are going to look at quickly is by ozonolysis of alkene. This is something that you've learned before. Now we said ozonolysis, we give an ozonide. Right? Did you learn this in your year 1? Yes. Now, when alkenes react with ozone, they are going to give an ozonide. Then when this ozone decomposes with zinc and water to give either an aldehyde or a ketone, or a mixture of aldehyde and ketone. It can either give 2 aldehydes or 2 ketone, or aldehyde and ketone. So we can form two different aldehyde, 2 different ketone, or aldehyde and ketone. 2 products must be formed. The 2 products is, one can be aldehyde, can be ketone, and it can also be what? Aldehyde or ketone. You see it? Exactly. Depending on the symmetry or the geometry of the word alkene. That means it is the alkene that will actually determine whether it will form an aldehyde, ketone, or aldehyde and ketone. Is that okay? So this is going to give us CH3. Here will be CH2. Here will be C double bond CH3. Here will be hydrogen. Here will be hydrogen. Now in this case, this reaction is very, very easy. It's not something that you need to waste time on. So if you have react with ozone, then you have zinc and water. The mechanism was not specified for you here. Now what you just do is you break this into 2. Alright? Now to this end put a double bond, to this end put a double bond oxygen. Are you getting it now? At the seat of the double bond, you divide it into 2. To this end put double bond oxygen, to this end put double bond oxygen. That is the answer to that question. So here will be CH3. Here will be CH. Here will be what? C. Of course, you have hydrogen. I told you to this end put double bond oxygen, plus to this end put double bond oxygen, and then you have C, H, and then CH3. What compounds are these? This is an aldehyde. As you can see, it has C hydrogen, then carbonyl group. If you want to bring this out in a way that you can see it very well, you have CH3, CH2, then C double bond O, and then H. Or you can have C, this CH double bond oxygen, CH3. Is that okay? So that is ethanol. Why this is what? Propanol. Do you understand that? Exactly. So that is the method of preparing aldehyde or ketone, depending on the geometry of the starting material, which is the alkene. So for instance, if you have a particular alkene like this will form aldehyde. So if you have an alkene that looks like this, what do you think the product of this reaction will be? Now, if you divide this, told you that for ozonolysis, all you need to do to get your answer, divide that at the middle, and then you have CH3, C double bond O, here will be CH3. This is a ketone, the way it is, plus here will be double bond oxygen, CH2, CH3. This here is an aldehyde. Here is supposed to be CH, not CH2. So we'll have CH, CH3. Here's an aldehyde, and here is what? Ketone. So that is for ozonolysis. Is that okay? Ozonolysis.